If an even number is divided by 2, the coefficient is always an odd number. By taking an example, we will check it out whether this statement is true or false. Take 100, which is an even number. When it is divided with 2, we will get the remainder as 0, and 50 is the coefficient, which is an even number. So this is false. Okay. Next one. All prime numbers are odd numbers. Is it true? It is false, because 2 is a prime number, but it is an even number. So all prime numbers are not odd numbers. Prime numbers do not have any factors. This statement is false, because prime numbers also have factors as 1 and the number itself. So prime numbers do not have any factors is the false statement. If you can take 3 as an example, which is a prime number, it is having the factors of 1 as well as 3, the number itself, are acting as the factors. Sum of two prime numbers is always an even number. We will take two prime numbers, 7 and 2. If we can add 7 plus 2 is equals to 9, which is an odd number. So this statement is false. Next one. 2 is the only even prime number. This statement is right. This statement is true. 2 is the even as well as it is the lowest prime number. So this statement is true. All even numbers are composite numbers. No, this statement is false, because if you can take 2 as an example, it is an even number, but it is not a composite number. Next one, the product of two even numbers is always an even number. We will check by taking two even numbers and multiply them. For example, 4 and 6. If we can multiply these two numbers, we are going to get 24, which is an even number. So the product of two even numbers is always even is a correct statement. So it is true. Problem number 3. The numbers 1, 3 and 3, 1 are prime numbers. Both these numbers have same digits 1 and 3. So what we have to do? We have to find such pairs of prime numbers which are having same digits up to 100. The required pair of prime numbers with same digits are, see here, 1, 7 and 7, 1, 17 and 71, 3, 7 and 7, 3, 37 and 73, 7, 9 and 9, 7, 79 and 97. If you can see these pairs, they are having same digits. Okay. Write down separately the prime as well as composite numbers less than 20. My dear students, you should have to have the basics in your mind very strongly. What is a prime number and what is a composite number? So, the prime numbers less than 20 are, tell me, 2, 3, 5, 7, 11, 13, 17 and 19. So the remaining numbers are, yes, you are correct, they are composite numbers. The composite numbers are 2, 3, after that 4, 5, after that which is the missing number? 6, 7. So after 7, what are the missing numbers? 8, 9, like that. 10, 12, 14, 15, 16, 18. These are the composite numbers. Problem number 5. What is the greatest prime number between 1 and 10? Very simple. It is 7. The greatest prime number between 1 and 10 is 7. Express the following as the sum of two odd primes. So we have to take these numbers. See, 44. we have to express this number as sum of two odd prime numbers. 44 can be written as 13 plus 31. Similarly, 36 can be written as 17 plus 19, sum of two odd prime numbers. 24 can be written as 7 plus 17. 18 can be written as, tell me, 7 plus 11. It is the sum of two odd primes. If you can observe this scenario, next one, give three pairs of prime numbers whose difference is 2. If you can take two prime numbers difference, they are called as twin primes. They are called as twin primes. So the required pairs are, what is the condition? In between the prime numbers, the difference should be 2. 3 and 5, 5 and 7, 11 and 13. They are also called as twin primes. Okay. Which of the following numbers are prime numbers? 23. 23 is the prime number or not? It is a prime number because it is having 1 and the number itself as the factor. I'm sorry. Extremely sorry. 51 is the prime number? No, because it is not a prime number, because 51 is having the factors of 3 into 17. Okay. 37, yes, it is a prime number because it is having 1 as well as the number itself as the factor. 26 is not a prime number. It is having 2 into 13 as the factor. Write 7 consecutive composite numbers less than 100 so that there should be no prime number between them. We have to write consecutive prime numbers. Okay, they should be less than 100 and there should be no prime number between them. The required 7 consecutive composite numbers are 90, 91, 92, 93, 94, 95 and 96. These are the consecutive composite numbers. Next, 10th problem. Express each of the following numbers as sum of 3 odd primes. Sum of 3 odd primes. 21 can be expressed as 3 plus 5 plus 13. 3 odd primes. 31 can be expressed as 5 plus 7 plus 19. 53 can be expressed as 13 plus 17 plus 23. 61 can be expressed as 11 plus 13 plus 37. Okay. Next one, problem number 11. Write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. See once again, 5 pairs of prime numbers less than 20 whose sum is divisible by 5. Okay. The required pairs of prime numbers less than 20, they are 2 plus 3. Okay, it can be divisible by 5. 2 plus 13, this is equals to 15, can be divisible by 5. 11 plus 9, 20, which is again divisible by 5. 17 plus 3, 20, again divisible by 5. And finally, 7 plus 13 is equals to 20. divisible by 5. So these are the required pairs of prime numbers which are less than 20. Fill in the blanks. A number which has only two factors is called as a prime number, the number as well as itself. Okay, 1 as well as the number itself is called as prime number as the factor. A number which has more than two factors is called as a composite number. 1 is neither prime nor composite. The smallest prime number is, tell me what is the smallest prime number? 2 is the answer. The smallest composite number is, tell me what is the smallest composite number? 4. Okay. The smallest even number is, tell me students, it is 2. Okay. So with this we have completed the exercise 3.2. Next we will go for the next exercise.